Just let me do this. Before we get started, everybody. Okay, that's good. That's good. Well, let me go to my previous page. I'll just erase this and find just use this page. All right. Like I said before, I might have told you last week, 9.1, 9.2, 9.4, 9.5, 9.6. These will be predominant on the test. Okay? So you're talking 80% of your tests will be on those four sections. 9.3 will be probably the rest of the 20%. I might throw a 9.4 on there, but I don't think I will. All right. Now, what I would suggest you do on the 9.4, instead of me testing you on it, I just want you to make sure that you do the homework for it. It's mostly calculator, like the graphs, and I don't want to spend a lot of time going over that. So I'm just letting you, and you send in questions. Go ahead and send in questions from 9.4, and I'll cover them. But most of the questions in 9.4 you can do with calculator. Okay? So on 9.4, work on homework and send questions. I did get my email fixed to where the 111 questions will go over to the 111 folder now. So, so I'm going to finish 9.3 today. So that means Thursday will probably be homework questions or review. So that means next week will be the test. Also, I need you to come in and take another, what do you call it, in-class test. Maybe Tuesday. Somebody give me that date so nobody screws it up. Okay, somebody give me that date. What is that date? Can y'all look it up quick? Yeah. 14th? Is that the 14th? My dad's birthday. 11/14. Tuesday. Okay, y'all can't read the calendar. Okay. That's fine. The 12th. Whatever that Tuesday is. All right? So the test will probably start, let's see, we'll probably either we'll review here on this Thursday, or we will review on that Tuesday. Well, make this Thursday, so it will be the 14th. Yeah. 14th is Thursday. Yeah, just remind me which bridges y'all work on. Y'all become engineers and science majors. I just want to know what y'all work on so I could be weary of going around it. So probably this will be Thursday, the 16th. All right, so today we're going to finish up 9.3. You should be working and finishing up this and sending homework questions. 9.4, I want you to work on with your calculator and send in questions with it. But don't send them in Thursday. Don't send them in Thursday at like 10:45. All right, I need you to send them in, before Thursday. Okay, because those are calculator questions, and I got to go in and remember how to use the calculator and all that stuff. Well, I don't use the calculator that much. And here on Tuesday of next week, we're probably talking about the review if we don't go over the review Thursday. And then the in-class test will be on 11/16. Again, this is bonus points for you, so I don't want you to gap it off. I want you to take it. Did we take the first one? We did? Okay, just so I get 2 in. Then I'll shut everybody up. Okay? And so you're probably talking about the test starting either here or here. It basically depends on this right here. All right, so if you don't send any homework questions in, we'll probably review Thursday, and then everything will fall up pretty much. Okay, so that means if we start the test, if I review the test Thursday, then that means the in-class test will be bumped up to Tuesday. Okay, it all depends on this Thursday, and I'll go over all that Thursday, when we get there. All right. So with that being said, the first question we're going to go over, and I've already worked on it a little bit, is this one right here, double angle identities. So you might want to make a note on your sheet with your identities. You don't have to write them down. You just put a star beside them. That's what we're going over today. Okay, these are the double number identities. Sometimes they're called the double angle identities. And here's the question. Given cosine of theta is equal to 3/5 and sine is less than 0, that means negative. That means in the third and fourth quadrant. Find sine of 2 theta. Now, highlight the question. The question is this. That's what they're wanting. Cosine of 2 theta and tangent of 2 theta. Now, one of the things you're going to see about 9.4 is that it's basically plug and what? Plug and chug. It's not as calculating as you've been dealing with up till now. Now it's mostly plug and chug. But first you have to find what? You have to find the sine and you have to find the cosine. You have to find the sine. Now, how many different ways can you find the sine? 2. You can find with, as I showed you right here, the Pythagorean identity, or you can draw your what? You can draw your, you know that Oscar had a hump, so that's 5, and the adjacent is what? 3. So now you can just use your Pythagorean identity. 25 minus 9 is equal to 16, and the square root of 16 is what? 4. So now you can do it this way, or you can do it this way. You still get what? You still get 4/5. Now, y'all remember us doing that before with the other identities? Remember me saying that you could either find it this way or you can find it this way? There's 2 ways you can find the sine. I don't care how you do it, just so long as you find the sine. Now, the sine is negative. Or the sine is negative because of this. So whatever you get right here, you put a negative in it because of this right there. Now, it doesn't make that big of a deal because what are you going to end up doing to it later? You're going to end up, in some of the cases like this, does it matter here? No, because what are you doing to it? You're squaring it, so it really doesn't matter. Okay? So, now that you found the sine, part 1 is finding the sine. So put right here, part 1 is you're given the cosine, but you got to find the sine. So you did that. And now you plug it into this one right here, because they're asking for the sine of 2 theta. Sine of 2 theta is equal to 2 sine cosine, so 2 negative 4/5 times 3/5. There it is. All right, part 2, or second part. That's part 1. This is part 2. This is part 2 right here. Part 3. Find the cosine of 2 theta. Well, you've got 2 or 3 choices. You can use whichever one you want. I chose cosine squared minus sine squared because I'm squaring stuff. I don't make it positive. So cosine 2 theta is equal to cosine squared theta sine squared theta. Plug and chug, and you get negative 7 over 25. I think is that 7? What's 9 minus 16? Make sure it looks like something crazy looking. I think that's 7. Okay. Now I left this one. I started this one for you. Now I want you to finish it. They want the tangent of 2 theta. So I want you to take what I've given you right here, this little hint. I want you to put that tangent, put this right in here, and work it out, because all you're doing is plugging and chugging. Not really much, and I don't want you to take this the wrong way, there's not much brain work in these problems. Whereas 9.1, 9.2, 9.5, and 6, you're actually thinking a little bit better. Now I'm going to, I don't know if I'm going to be able to do this or not, but I'll try. I'll make it a little bit smaller. I don't know if it'll let me or not. Do the whole thing. Hold on. It would help if you have work with me instead of against me. I'm glad they trained us on these things. I really can't believe it worked. All right, so we've got tangent of 2 theta is equal to 2 brackets sine theta cosine theta over 1 minus bracket squared sine theta over cosine theta. So now you've got sine. The sine is what? Where's the sine? Where did I do the sine? Negative 4/5. So that's going to be 2 brackets negative 4/5 over cosine, where's cosine? 3/5 over 1 minus brackets, -4/5 divided by 3/5 squared. And that's going to give you 2 times -4/5 times 5/3, which will give you what? 2 times negative what? 4/3? You'll check my math. And 1 minus brackets -4/5 times 5/3 squared, which would be -4/3. So 1 minus the -4/3 squared. Y'all check my math. Y'all think I can think lightning strike twice? Well, I think it did for a second, didn't it? Oh my gosh, it did. And that's going to be equal to -8/3 divided by 1 minus brackets. What's -4/3 squared? 16/9. Have y'all checked my math? I mean, does everything look all right? Don't wait till the end of the problem and say, oh, you got that, and then somebody goes, yeah, I thought that was wrong. Don't do that. That makes me mad. -8/3 divided by 9/9 minus 16/9 is what? Negative what? -7/9. Help me out. What's 9 minus 16? -7/9. Yeah, Hubert. No, Hubert. I have no idea what's going on, Hubert. Okay, class. Okay, yeah, whatever. Just be quiet. All right. How does that look? And then the 3 will cancel with the 9. How many times? 3 times? I get 24/7. Somebody check. That's what I got. Somebody came in. Somebody's.
That's what I got that as well.
The answer is 24/7. I just checked. All right, now if you suck at basic math, then you might want to write that down because you need to refresh your memory on how to do fractions. That's why I saved that one. That's why I went ahead and did the first 2 parts, because that's basic plug and chug. This part takes longer than both the other parts because the teeth is bad. So this right here, let me do this in blue. This right here part 3 or part 4 right here. Now, the reason I picked this problem to show you is because you've got 2 or 3 questions in one question. If I was to give you a question on a test, it would be either the sine, cosine, or the tangent. I wouldn't give you all 3. Unless I give you like just one problem out of this section or something like that. It's part 3. That's 3 parts, or 4 parts. Actually, 3 parts. First part you just find in the assignment. And again, it's just plugging and chugging with fractions. And that's what you're going to see most of these questions are in 9.4 is plugging and chugging. All right, next problem. All right, these problems are called the double number identities. Where did Mr. Torres go? Somebody left.
I think Morgan left. I think.
Who?
Trying to look.
Miss Lovin?
Yes, I think so.
I'll see if she's still there. She's still there. She might have got kicked off. I'll add her just in case. Okay. So this one says cosine squared of 7x minus sine squared of 7x. So you've got cosine squared minus sine squared. You look directly up to your double number, and there it is. Cosine squared minus sine squared. So what is 7x? A is equal to 7x. Plug it in. A is equal to 7x. Therefore, cosine squared of 7x is equal to cosine squared, blah, blah, blah. Simplify. Notice it doesn't say solve. What does it say? Simplify. So there's your answer. Your answer is actually cosine 14.
And that's still part of 9.4?
Yes, this is now all this today is 9.4.
Okay, gotcha. Just make sure.
And this one says 2a is equal to 2 sine. That's where I get this right here. This is sine a cosine, sine a cosine, boom. Sine a cosine right here. Sine a cosine. But it's got a 2 in front, so you have to put a what? A 2 in front. So 2a is equal to 2 sine, and that's what we do. So to get rid of this 2, or to get rid of this 2 right here, because I want it to be a, to get rid of this 2, I multiply the whole thing by 1/2. And what that does is gets rid of the 2 here, but right here you have 2 sine 15, so by the law of sines, or cosines, or trigonometry, this 2 makes that a 30. Like here. And basically, you've got a special angle, right? So it's this right here. See, you can actually, or you could say this. You could actually say, well, this takes this out, and then what are you left with? Sine 15 cosine 15, which is basically this, transfers into that, which is sine of 2 alpha. So you could actually say that this gives you that right there. Sine 2 times 15. Okay, you can't look at these as the sine of something and the cosine of something where you did in the first problem we did. This is a different problem. This is a different identity. That's why it's so important for you to have those identities in front of you so you see what to actually do. Now, once you do about 2 or 3 of these in homework, you'll know which one's which. Okay? Again, plugging each other. Let's try another. All right, you try this one. And I even checked you which one checked the one that you need to use, because this says 2 theta sine theta, and cosine sine. I'm sorry, I didn't see that. Cosine sine, cosine sine. There's no other cosine sine up here. So cosine sine, you immediately go to that portion. Cosine 2 theta sine theta. Okay, I'm putting it right up under this one. Cosine A sine B is equal to 1/2 sine of A plus B minus sine of A minus B. Okay, now what is the first thing you're going to do? What's the first thing you're going to do after you write the rule or the identity under the problem? What are you going to do? Figure out what is A and what is what? B. It's pretty simple. It's plug each other. So A is equal to 2 theta and B is equal to what? Theta. So do what you're supposed to do. This one's really hard. I may put this on the test because it's so hard. Equals 1/2 sine of 2 theta plus theta minus sine of 2 theta minus theta, which is equal to 1/2 sine of 3 theta minus sine of theta. And the only thing you can do there, if you wanted to, and I'll put 2 arrows here, you can leave it like that, or you can distribute the what? The 1/2, Hubert. That's right, class. One of the biggest things that students ask, why do we have to do these identities? The identities, if that's the way you spell it, the identities are to trig and calculus what factoring is to what? To algebra. Okay? You basically spend pre-algebra, algebra 1, algebra 2. Some high schools have algebra 3, which is a good thing. then trig or pre-cal, because algebra 2, 3, and trig in high school is what they call pre-cal. And then calculus, and then calc 2, and then calc 3, and then DPQ. So if you are an engineering or science or a non-literature major, how many years is that? Basically, you're talking about 1 to 2 years per, okay? So let's do 2 per, one per semester. So that's 1 year, that's 2 years, that's 3 years, that's 4 years, close to 5 years. Now, what are you doing in all of those 5 years? You're taking a problem, and what are you doing to it? You're busting it what? You're busting it apart, and then what are you doing? You solve it, and then what do you do? You put it what? Back what? Together. Nobody is ever going to walk up to you and ask you, well, can you tell me what the cosine of 2 theta looks like the sine of theta? Nobody's going to ask you that. But as an engineer or a science major or somebody solving problems of computer science or computer engineering major, you're going to be asked, or a mechanical engineer on a industry somewhere, you're going to be asked to use this training for your brain right here to take stuff apart, put it back together. That's why an old mechanic is a whole lot better than a new mechanic when you talk about taking something apart and putting it back together again, because the old mechanic has done it over and over and over and over. This is nothing but problem-solving training for your what? For your brain. Taking stuff apart, putting it back together. Taking stuff apart, putting it in the same manner, and putting it back together. So you're rewriting all these identities, all these things right here, you're rewriting them in a different way. So I usually have that spiel before the identities, but usually when you get to this part, you're actually saying to yourself, why are we doing this? Nobody's ever going to ask us this. No, they're not. But if you don't do all of this right here, if somebody asked you to turn a doorknob, you wouldn't be able to do it. Because you don't have that critical thinking part of your brain developed. And by the time you're 12th grade, 8th or 9th grade, that critical thinking takes off right here at pre-algebra. Okay? So you're talking about 5 or 6 years of nothing but taking problems apart, putting them together again. So when you get to Michelin, or you get to Fleur Daniel, or you get to whatever job that you get to, and somebody puts a problem on your desk, not a math problem, but a problem having to do with your field, the first thing you're going to do is, okay, the problem is blah, blah, blah. Well, let's bust this up and see what the problem breaks up into, and let's see where some of the problem can be contributed to this, or some of the problem can be attributed to this, and let's see if we can take that part out and put something in its place, like a plastic part, or a composite part, or an arm, or a leg, or not a physical arm or leg, but a plastic arm and the leg, to do this or do that, and then put it back together. That's the whole point of this. So I'll shut up. All right. Yes, sir. Discrete math is the study of numbers. The reason you need that is because you're computer science, aren't you? You've got to understand binary and non-binary operations. 0 is yes, 1 is no. You've got to understand what the binary operations, and what if you don't have a base 10 system? What if you have a base 8 system? Then there is no 9 and 10, or 9 and 0. It's 1, 2, 3, 4, 5, 6, 7, 8. You only got 8 numbers in your universe. So that you only have those numbers. That's discrete mathematics. Combinatorics, that's what it's under. the theory of numbers is what discrete mathematics is. So you will be able, as far as the math goes, it's a given. But a good question for that would be something like this. In a combinatorics field, I'm getting off kilter here, but we'll be all right. That's the next problem. In a combinatorics field of 0, 1, 2, 3, what is 2 plus 2 in a combinatorics field of 0, 1, 2, and 3? 2 plus 2 is equal to 1. Here's your 2. 1, I'm sorry, equals 0. 1, 2. You're adding 2 letters. You're adding 2 more numbers. Okay? You don't have a 4 to go to because this is your universe. And it's the theory of those type instances to where some numbers cannot be used. Just like in a computer system, you can only use 0 to what? To 9. What if you get more than 9? Well, you got to go to another program. You got to go. That's what discrete is. Okay. All right, try this one. Again, it is I've already marked the one that you need. How did you know to need it? Well, it says sine minus sine. Which one has sine minus sine? These are just like the factoring problems, the shortcuts. Remember the shortcuts in algebra? It's just like them. You're learning how to take away, you're learning how to break up something that is in a common fashion. So I'm just going to rewrite the problem. Sine of 2t minus sine 4t. And I'm going to go sine A minus sine B is equal to 2 cosine A plus B of 2. Make sure I write it down right. Yeah. Sine A minus B. All right, now this is the question. Can you answer it? What is A and B equal to? So your answer is going to be 2 cosine. I'm going to go ahead and jump a step. What's 2t plus 4t? 6t here, but thank you, class, for being interactive. Sine of, what's 2t minus 4t? So you've got 2 cosine of what? 3t times the sine of what? Negative t? Y'all check it. Now, that's probably going to be it. You could put that negative out in front. You could. I don't know if that's what they want. You could put that negative in front of the side, which would come out in front of the 2. Let me see what they did. Which one are we doing? And I lost my place. We're doing sum to product. Oh, I'm sorry. I then got behind. No. Yeah, they did. They brought it out. But if you look on your sheet, on your formula sheet, somewhere there's a bunch of negatives. That negative can come out, and if it comes out here, it can come out in front of this sign right here, and if it comes out in front of this sign, this negative right here, it can come out right here, and if it comes out here, it can also come out here. So you can put that negative. I don't really care where you put it. Don't matter to me. So now it's negative 2. You could have 2 cosine 3 theta times negative sine of t, or you can have 2 cosine 3 t times the sine of negative t, or you can have negative 2 cosine 3t sine of t. Either one of those answers is correct. Doesn't matter. They like it like that because the negative's out front. And when you're talking about taking the derivative or taking the antiderivative, that's good because the negative's out front. And when you get taking the derivative, the negative will go. It'll be better out front. That's why. Yeah. And the last one. This one. Now this one, you're going to have to think just a little bit at the beginning. Now you know it looks like the cosine. It looks like the cosine, so you know that you're going to use the cosine. That's not a big deal. But the problem is, you got to have something over 2. So, you've got cosine of pi over 12, but that doesn't help you very much. Cosine of pi over 12 needs to look like the cosine of a over 2. So how can we make, so what you do, this is a trick I've learned, you just do this. Multiply this by 2 in your head. What do you get? In your head. Just multiply 2 times pi over 2, 12. What do you get? Pi what? Pi over 6, Hubert. Yes, that's right, class. So cosine pi over 6 over 2. And now A is equal to what? Okay. Do this in your head. Multiply this by 2. That's not written correctly. I'm sorry. Do this in your head. Pi over 12 multiplied by 2 over 1. Do that in your head. Mentally. The reason I multiplied by 2 is because over here I divide by 1. So I'm trying to figure out what's my number up here to divide by 2. So I take this number and multiply by 2. I'll take this term and multiply by 2. And now you've got A. So A is equal to pi over 6 plus or minus square root of 1 plus cosine of pi over 6 divided by 2. Well, let's see. What is pi over 6? Pi over 6 is equal to, or multiplied by pi 180, is what? 30 degrees, right? Which is 1 square root of what? 3 and 2. Cosine is equal, Oscar had a hump, which is a hump, square root of 3 over 2. So plus or minus square root of 1 plus square root of 3 over 2 over 2. So 2 over 2, so that's going to be 2 plus the square root of 3 over 2. I don't know if they go this far, but that's going to be 2 plus 3 over square root of 2. 2 plus square root of 3 over 2. And then divide by 2 over 1, which means you multiply by what? 1 over 2. That's right, class. Well, you get the point. And that's going to be 2 plus the square root of 3 over 4. Two plus the square root of 3 over 4. And that's why I'm positive or negative. I don't know how far they take this. Positive or negative. Square root of 2 plus the square root of 3 over 2. And you can take 2 plus the square root of 3, that's what, 3.7? So positive or negative, 3.7 over 2. I don't know how far they take it, but I'm just going to stop there. They didn't take it much further. They just did 2 plus the square root of 3 over 2. Is that what I got? Yeah, they didn't go very further.
Yeah.
Now, the whole point of this section that I'm giving you on this is just so you could be able to plug and chug and be able to pick the problems out by the way they look. Like this one right here. It says cosine. The cosine. Well, that's sine. That's tangent. That's tangent. That's tangent. So it can only be this. Okay, that's the first thing I'm trying to get across to you. Which one do you use? And then after you get it to which one you use, then you take this guy and you figure out how to use this guy in the plug and chug. Now in this one, you have to think a little bit. With these half number identities, you're going to have to put this part in here, this middle part, that's going to be first. Because you've got to figure out what am I being multiplied. If I say the cosine of 60 degrees, then you know automatically A is 120. See? You've got to put that part in your with the half angle. These are also called half angle. What is yours called on that sheet? Is it called half angle or half angle? Green sheet. Where is it? Let's see. Half angle. See, they're called half angle. So whichever they are. Question, right, complaint. Okay, so what I want you to work on now is I want you to work on 9.1, 9.2, 9.3, 9.5, 9.6. I want you to get those homework problems done first. Then after that, I want you to go back to 9.4 and work on the calculator and send those homework questions in. And come Thursday, we'll go over homework questions. Okay? Skype people, you good?
Yep.
Any questions?
I'm good.
All right, y'all get out of here.
Nope, everything's good.
See y'all Thursday. Yes, sir. What was your question? What questions? Everything's on there, yeah. Send them in if you have questions. Ask my instructor. That's what I use to review on. All right, y'all have a good one.